Good evening. I'm going to take the screen. And transfer it over to Melissa. Okay, good evening. It's my pleasure to introduce Melissa Burkhead, who will be presenting on the unit circle and trigonometry. And without further ado, I will make sure we can all hear Melissa. And we will get started. So Melissa, take it away.
Thanks a lot, Andres. Hello, everyone. Thanks a lot for spending this next hour with me. Today we're going to work with getting Triggy with it, the dynamic unit circle with the geometric series follow-up. As Andres stated, my name, you know, I teach at Trinity Valley School, and I teach geometry, and I teach pre-calculus and BC calculus there. My email is located right here if you ever want to contact me. As we go through this experience, I plan to create a unit circle and represent 6 trig ratios: sine, cosine, tangent, cosecant, secant, and cotangent, geometrically, and then we'll delve into how that can connect with concepts of domain, concepts of range, etc. Also, we'll do a follow-up with a nice geometric series problem that I like to connect when we're working with the unit circle. I have some materials that I will be posting on the site, or you all will be receiving via email, which will consist of the pre-made sketch of what we're doing today, where I have little buttons where if you wanted just to present this in class, you could press button, inhale, exhale, move on to the next page, and progress. But I also encourage you after the fact, maybe watching the webinar again, to give this a build and see where you can go. In addition to that Sketchpad file that I'll post, and we'll try to post it in both version 4 and version 5, we will have a Microsoft Word document, and this is just what I use in the classroom, the questions that I ask my students and the relationships. So there we go. I guess we'll get this party started. I'm excited. How about you? Just as we start, how was this first page where I have, how was this first page created on Sketchpad? Does anyone want to comment via chat? How do you think this first page might have been created? Animation, there you go. First, if you're ever interested in getting a yellow background, one would go to Edit Preferences, go to Color, and you could choose the color that you'd like. I know that my students often they're very interested in that, and that truly personalizes their sketches. And with parameters, I see Michael or Ruben have stated sliders or parameters. Well, if we go to our Show All Hidden, Display Show All Hidden, it looks like I chose the parameter route, and I've just graphed about 4 different functions, and I've animated those parameters. So I just thought that we would start off there. Now we will officially get Triggy with it. So I'm going to go and just build a new page on Sketchpad. To do that, one goes to File, Document Options, Add Page, and let's go to a blank page. What I'll do first is I'll create my unit circle, and I'm going to I'm going to change a few of the labels that you'll see occur when I build. But I hope that stays in line with my notes, and so hopefully things will run smoothly. So I'm going to create this circle here, and I'm going to create what may end up being an x-axis down the road, and I think I'll create a perpendicular to this line segment through that point. To do that, I would need to select this center. I would need to select the line. I'll go to Construct, and I shall construct the perpendicular. So now I would like to do a little labeling. I am going to call this point O. I'm going to call this point right here C, and I'm going to call this point here F. Now, if I would like to, I'm going to do add a little reflection in my life, where I've reflected point F in this line that I'm denoting right there, and I shall label it. And then I think I'll reflect point C in this line. So I shall label that point. Now I'd like to set up the givens of the situation. So I will have given circle O, and I can do that with hot text. Someone suggested that yesterday, with radius 1 unit. Now, I'm not going to use the hot text for my next line because I'm just going in line with my notes, and I want to say segment FC is perpendicular to segment CO. Ooh, not FC. I want to say FO, pardon, is perpendicular to segment CO. And I can just note that appropriately with this wonderful equation editor. And I also would like to know that segment, I've stated that my circle has radius 1 unit, but I'm going to actually say C's coordinates are 1, 0 down the line there. And let's just spice it up and say O's coordinates are 0, 0. Now that we've established these quadrants, we need to really define our angle we plan to apply to our trigonometric functions. On circle O, we're going to construct point A. So I'm just going to place this point A on the circle and label it. And so that you all will really understand the angle to which I'm referring, I'm going to create this arc CA, of circle O. One creates an arc. One way to create an arc is to select the endpoints of the arc and the circle, go to Construct, and boom, I have that arc. Now I'm going to apply the trig functions to angle COA. That's really where I'm most concerned. Therefore, I'm going to construct this line right here. The next thing that I want to do is I really want to create a few tangents. So I'm going to create the line perpendicular to the line that I've just selected, line OC, through point C. So I've performed the correct selection. I'd go to Construct, Perpendicular. Now, where my line here, and I might just make that a different color so that we can reference it down the road, where this green line intersects the blue vertical line, I'm going to call that intersection point E. Oh, that's not right. So there we go there. The next thing I want to do is I want to create another tangent to my circle 3 point F. So I will select point F, select this line OF, and construct the perpendicular. I'm going to go back to get that same blue color. where this newly constructed blue line intersects the green line, I'm going to name that point of intersection D. Finally, I would like to construct one more perpendicular to this line selected here, line OC through point A. Where that line, newly constructed line, intersects line CO, I'm going to call that B. I'm going to hide that line and just focus in on that line segment AB, and then I just want to construct this line segment OB. So now we are ready to get this party started, I believe. So let's think about this. My main goal is really to consider angle COA. And then I want to focus in on this triangle AOB. So I'm really thinking about this beautiful seafoam triangle, and I really want to think about angle COA. And let's go to this right triangle, and let's start thinking of geometric representations for the sine of angle BOA, which actually happens to be COA also, etc. Can someone give me a geometric representation, or give me the ratio of the sine of angle BOA? Through your chat, could you share the ratio of the sine of angle BOA? Okay, I'm seeing AB to AO. Does anyone want to agree with Stuart, or do we want to, okay, AB to AO. Okay, there you go, looking great, looking great. Therefore, as we think about this, AB to AO, well, what do we know about segment AO's length? Exactly. Therefore, this line segment AB can be a fine representation for the sine of angle BOA.
Hi everyone, this is Andres again, and it does sound like Melissa's audio just went out. Hopefully, see if she comes back in.
Okay, muted.
Okay, you're unmuted again. Yeah,
can you hear me? Can you hear me?
Yes, Melissa, we can hear you.
Yes, okay. I'm in.
Yeah, I'm hearing a little bit of static.
I don't know. I don't know why that.
And you did just drop on us all suddenly also.
Right.
Okay.
Okay, can you hear me now? I hear the static also. Let's give this a whirl. Are you still hearing a little static?
Oh no, perfect. Yeah, you just got rid of it.
Okay, I switched earbuds, but who knows what that means. Okay.
All right.
Okay, well, excellent, excellent. Thank you very much, excellent. So this line segment AB can be a representation for the sine of angle COA. Is there any time in which segment AB's length is 0? Yes. When is segment AB's length 0? What is the measure of angle COA when segment AB's length is 0? We have 0 or pi. There we go. Let's take a look. I can measure that angle, and I'm going to measure the arc angle, because when I make my angle greater than pi radian, I will get a nice reading. So let's select this arc, go to measure that arc angle. Is anyone going to sign out because we're working with degrees? Will that work? We can go both ways? Well, anyway, as stated, when the angle is 0, or when the angle is 180 degrees or pi radian, the sine of that angle is 0. So that goes in line with what we know trigonometrically. Now, when my angle is greater than pi half radian, less than pi radian, is the sign positive or negative? When my angle COA is in the second quadrant, is the sign positive or negative? Catherine says that, well, sign is still positive, and then I love seeing your plus signs. But notice that when my angle goes into the third quadrant, do we have a negative representation? And we can see that. And that's helpful for the students. I know that the students learn that all students take calculus or what have you on that end, but I think that this physical geometric representation is quite helpful for our students. What do we expect is going to happen when our arc angle, or our angle COA, is in the fourth quadrant? Again, we do have that negative. Now, I'm just going to select point A, and I'm going to create an action button that is an animation, and I'm going to make that point move along the circle slowly. And how can we take a look at this animation and say something about the domain of the sine function? Does anyone want to make a comment? The domain of the sine function. How can we connect this with the domain of the sine function? The domain's all real numbers. We have this segment's truly defined for any angle measure. Boom. Thanks a lot for sharing that. Now, what ratio would be representing the cosine of angle BOA? OB. All right. The ratio would be OB to OA, and OA again is 1. So there we go with that segment BO representing the cosine function. Now, what's the cosine of 0 degrees or 0 radian? 1. What happens when our angle is 0? What do we know about the length of segment BO? It's 1. And so students see this confirmation, this physical and geometric confirmation. When our angle is 180 degrees, what's the length of segment OB is 1, but in what direction are we really working? In the negative direction. Is that working for everyone? Now, how does this animation right here connect students with the idea of the range of both the sine and the cosine functions? How does this animation help students find insights about the range of the sine and cosine function? Okay, the range runs from -1 to 1. Thank you very much. So we've talked about 2 of the trig ratios, and now we have 2 representations. Now let's invite tangent to the party. What is the ratio of the tangent of angle BOA in right triangle BOA? What is the tangent ratio? AB to OB. Correct. Now, why does the plot thicken here? Well, OB doesn't have length 1 unit constantly. Correct? Is there any other triangle we can invite to the party to explore? Maybe to find some sort of geometric representation of what the tangent of angle BOA could be? I see some ratios here. Why is triangle ABO similar to triangle ECO? Why is my lavender triangle similar to the dark lavender triangle? Yes, by angle. Therefore, the tangent of angle BOA is segment AB to segment BO, and that, due to corresponding parts of similar triangles, we know AB to BO equals EC to CO. So if I have EC to CO, what's special about CO in relation to the circle? 1. Boom. Therefore, the tangent of our angle in question, angle COA, angle BOA here, would be a geometric representation would be line segment EC. Now, what do we want our students to tell us, to share, when we ask what the tangent of 90 degrees is or the tangent of pi halves? It's undefined. Well, what happens when our angle in question is 90 degrees? What's happening to the length of segment EC? In fact, I could create a movement button that takes A to F, and I could ask, what is happening to segment EC? That segment is approaching an infinite length. Okay? Now, does that demonstrate to you that the tangent of 90 degrees is undefined? How does this connect with the tangent of 0 degrees? What is EC's length when our angle is 0 degrees? 0, and the tangent of 0 is 0. What about when we go over to the second quadrant? In the first quadrant, what's the slope of this wonderful line? It's positive, correct. And it does look very close to 1. In the second quadrant, what's the slope of this green line? Negative. And what is tangent's sign in the second quadrant? Negative. When we take the tangent of pi radian, where's EC? I don't see EC. Oh, where is EC now? Do you all see EC? In the second quadrant, many look at this line and think of the connection with slope and tangent, and that line has negative slope. But do we also see that this segment EC is below our x-axis? Therefore, we have this negative representation. I too think it's cool. Carol? Now, what's going to happen when we pop this angle into the third quadrant? Well, here we go. Tangent of our angle is positive in the third quadrant, and here we get that nice representation. Now, as this point moves along the circle, we're predicting. What do we predict? Where do we predict that point E is going to move when we get our angle into the fourth quadrant? I think we're thinking it's going to go below our x-axis. Well, let's take a look. And again, we see this representation. So this is one way that I really like to have my students experience the mathematics, because they can see a physical model. They see this geometric model as opposed to the little mnemonic devices that we learn. So this is part of where we're going, but I think we need to continue on with discussing those trig ratios. So segment AB is our sine, segment OB is our cosine, segment EC is our tangent. How could we go about finding the secant? What ratio in our right triangle would represent the secant of angle BOA? What ratio would represent the secant of angle BOA? AO to BO. Now let's think about this. Segment AO to BO. Well, BO's not 1, and then that's saying, yes, that's 1 to BO. But again, that's not going to help us find this single segment that can represent the secant of angle BOA. But let's invite triangle ECO to the party again. Angle AO to BO would be equal to what, looking at our second right triangle? And I'm saying this is our first right triangle, this is our second. AB to BO would equal, segment AO to BO would equal EO to CO. Excellent, EO to CO. But again, we know like segment CO's length is 1. So which of our line segments would represent the secant of angle BOA, which happens to be angle COA? EO. Now let's think about the question, where is secant undefined? At what value theta is secant undefined? Okay, well let's look at pi. I see a 90, I see pi halves. Let's think about this. Secant is the reciprocal of cosine, and cosine is 0 at 90 degrees, at 270 degrees. So let's take a look at what's happening to segment EO when I make my angle 90 degrees. What's happening to segment EO? In fact, I suppose we could measure segment EO's length. We could look at this numerically. As this point moves closer and closer and closer and closer to F, what happens? Infinity and beyond. Okay. So segment EO is a geometric representation of the secant of our angle in question. Now, what is the secant of 0 degrees or 0 radian? 1. Well, let's take a look at segment EO as our angle becomes 0 degrees or 0 radian. What is EO's length? According to our unit circle, I'm going to hide that. 1. So do you see a nice geometric representation of this reciprocal function? When is secant -1? When is secant -1? Secant would be -1 when cosine was -1, and that's at pi. Well, let's take a look. Here is EO. Notice that in the second quadrant, secant would be negative. Is that working for everybody? Therefore, when our angle measure is pi, what do we see is happening with EO? Is that working for everyone? So again, I like to ask the question to the students, how do we connect the length of segment EO, how do we use that representation and connect it to the domain and range of the secant function? Well, in the range world, does segment EO, what do we see is happening with segment EO? Okay, minus infinity to infinity. Well, does that mean that EO's length is going to be 0 sometime? Will it equal -1/2 sometime? Will it equal 1/2 sometime? Ah, it's the absolute value of segment EO is greater than or equal to 1. And we can see that model physically here. EO, from the distance from this point to this point, the distance from this point to this point never is that distance is never going to be less than 1. So, how are we feeling about these representations? Again, hopefully, I'm thinking that this is one more way to communicate to students. Does this representation touch each and every student in the class? Of course not, but it does key in with a group who appreciates the physical, and I think that I know that it's benefited my students. So let's continue on. Let's talk about the cosecant. Now, do the students follow a worksheet to explore the trig functions the way you showed, or do you demonstrate? You know, Sangeeta, that is a great question, and I've been doing this for, this is my, I guess, 19th year of teaching, and I've been on Sketchpad since 1997. I'd say that it depends. If I can find lab time for my students, we go to the lab and they walk through this experience, but there are times in which we just lead it in a group way. One thing that we will be posting via this webinar will be this document, which is the dynamic unit circle with the geometric series follow-up, and essentially you go through exactly what I'm demonstrating right now, and you can see the order that is happening. Are you following that, Sangeeta? And then as we progress through, I have them fill in some blanks, and then I ask them the questions about domain, about range, and things of that nature. So that is, I use this mainly as a guide. It truly, I truly decide on how it's going to work this year, and I might even do different things with different sections. Exactly. And just to follow up on, I want to go back to our mathematical exploration, and it's going to happen for us. But this will also be available where this is essentially a walkthrough of, okay, student, what's the sine of angle BOA? And then you could push a button that had the answers and things of that nature. You could push buttons that had all the answers. And we just walk through all of these experiences. But I often think that it's quite helpful to build it just from scratch, because the students respond. There's a little more excitement, I feel. There you go, Eileen. A physical model and then use Sketchpad for modeling the geometric representation. Excellent sharing. Excellent sharing. So we now are going to move into talking about the cosecant. So switching gears, or let's go back to our representation, can someone share with me the ratio we would be using to find the cosecant of angle BOA? So I see AO to AB. Excellent. Now, this is where it gets a little dicey because when I look at AO to BO and I compare it to OE to EC, I don't have that unit length that I've been depending on. So I think I'm going to invite another right triangle to the party. Is this purple triangle, triangle DFO, similar to triangle OBA? Triangle DFO, similar to triangle, triangle DFO, similar to triangle OBA? By angle. All right, sounds great. Now, could we say AO to AB is equal to OD to OF? AO to AB is equal to OD to OF. What's special about the length of segment OF? 1. So, which of the line segments represents the secant of angle BOA? Which of our line segments represents the secant of angle BOA? DO. Now, when should DO's length go infinite, or as you all like to say, to infinity and beyond? For what angle measure would DO's length go infinite? It's 0, because 1 to sine of 0 would be infinity. So let's make this angle 0. Do we see how segment OD becomes undefined? Let's make our angle 180 degrees, or pi radian. Do we still have OD being undefined? When we make our angle pi half radian, what's special about the length of OD? When we make our our angle pi half radian, exactly, it's 1. When we make our angle 3 pi half radian, we get that -1. So again, we see these nice, quick, painless geometric representations of our trig ratios. So the last trig ratio that we'll delve into is the cotangent. Now the cotangent ratio is, what is the cotangent ratio of our angle BOA? OB to AB. So if we have OB to AB, that would be equal to FD to OF. Once again, since FO is 1 unit in length, which of the segments would represent the cotangent of our angle in question? You've got it, segment FD. And notice that when we make our angle 0, what is the length of FD? It's going to infinity. When we make our angle pi half radian, FD is going to 0. If we make our angle 180 degrees, or pi radian, FD, going infinite. We make our angle 3 pi half radian. So we see this nice geometric representation of the situation. So this is essentially the dynamic unit circle portion of the webinar. What were your thoughts so far about this walk? Good, bad, ugly? Have you seen, were you aware of these line segment representations? Excellent. I know that we could build many different right triangles, and we can find other nice representations, but I know that I think it can help our students, and it's quite easy to build. It's quite easy to build. Does anyone have any question about what's happening here before we move on to the next type of problem? Any questions, comments?
Hey, Melissa, this is awesome.
Yes.
You get all kinds of great positive feedback, and I think this is wonderful. I did want to mention with the angle marker, you know, you're also able to make an angle marker go from 0 to 360.
Excellent.
Yeah,
how does one do that? Show me that.
If you just construct the angle marker,
right,
and then select it with the, you have to go back to the arrow tool.
Okay.
And go to its properties. You go either right click or edit properties. And then,
so I'm in. Okay. I want to show people because I doubt I'm the only one who wasn't aware of this. So I'm going to hide that puppy. Yeah. Okay. So here I've selected in properties.
And then in the marker tab, you can make it be counterclockwise.
Excellent. Thank you.
It's simple, and then the angle will exist from 0 to 360.
And I just need the 4 strokes now. Just we'll go. Yeah, I'll just play around there. So thank you very much, Andre. So there you go. Is there? Well, here I'm trying to show an angle that is between 0 and 180 degrees, though, and what's happening?
Yeah, it doesn't look like it was formed off of the 2 segments that we wanted it to be
okay.
formed off of.
Okay, so I would just need to play around with that.
You can also make it, when you create the angle marker, that you drag from the one segment to the other segment.
Okay. Okay.
Anyway, I think that was
okay.
great.
Well, thanks a lot. Okay. Well, then I think we'll move on to the next problem. And how do we? I hear, how do we convert to radian? You can select your angle measurement, go to Edit, Preferences, Units, change this to radian, and boom, you're in business. So I hope that helped, Catherine. So this was the dynamic geometry portion of our, well, we'll still do a little bit more dynamic unit circle. But let's go to File, Document Options, and let's just add another page. Now, the next thing that I want to do is I just want us to think about something. I like to often put on an exam when students are working with the unit circle. So I might say, hey, what if we started with a line segment, okay, and I find the midpoint of that line segment, and I construct this circle, and then I go and construct the perpendicular to this line segment through this point. Now, the next thing I want to do is just find the point of intersection that I've made here. And I'm going to select this point, this line, this circle, go to Display, Hide Objects. I'm going to create this line segment, and then I want to create the line parallel to this line that I've selected through this point. And then I'm going to construct this little perpendicular where these two lines intersect. I'll find their intersection. And I will construct this line segment here. So the next thing I'm going to do is I really enjoyed that experience, so I think I might do it again and again. So I might perform this mathematical iteration where I take these 2 points and map them into these 2 points and see what transpires. So I'm going to go to this number, I'm going to go to new parameter, and I'm going to iterate to depth. And I'm going to establish the value of 1 right now. The next thing that I'm going to do is I'm going to, again, I stated I was going to iterate. So what if I selected these 2 points, hold down on my Shift key, select this iterate to depth, and go to transform, and notice I'll have this iterate to depth feature. Iterate to depth allows me to control the iterations a little bit more precisely. So here I'll map this point into this point into this point, and click iterate. And notice I could select my iterate to depth. I can access my plus key on my computer. And what are we actually seeing here? Does anyone, what am I doing here? What's happening to these segments' lengths? Anyone? Anyone? Okay. Okay, our lengths are approaching 0, and we have this geometric series. Okay, let's think about that. I wonder if we could combine that with what we know about our unit circle. I'm going to rotate this point about the center of my circle, and I'm going to do it 45 degrees. And then I'm just going to construct this radius, and then I'm going to construct the perpendicular as such. And I like to put this type of problem on my test to see where students will go with it, because in Algebra 2, my students work with geometric series, and I bet a lot of your students work with geometric series. And so this is a nice connection when we're working with the unit circle. So I'm going to merge this point into this point, and I'm going to merge this point into this point. Okay. Now, if this point right here has coordinates 0, 0, and this point has coordinates 1, 0, and you saw that I rotated F about 45 degrees, what would the coordinates of F prime be? Okay. So, okay, I see a square root of 2 divided by 2. So here, I'll just put this over here to give us a little perspective, because I want to see where we can go with this. So, essentially what I do with my students is I might give them this problem right here. And I don't know if I sometimes build it on Sketchpad, sometimes I just give them a static drawing, but I thought we could share it. And then I'd ask them, what would the sum of the lengths of the segments shown be if our pattern continued indefinitely? What would be the sum of the lengths of the segments if our pattern continued indefinitely? I've heard people say geometric series. Okay, I follow. Now, when we constructed our first little segment before we did some building, if this segment right here has length √2 divided by 2, what would the length of that segment be? Well, I'm going to go over here and do the construction one more time because I understand that you might not remember. I constructed this circle. I constructed this perpendicular. Okay. Now, what is special about this segment right here? Or what's special about this triangle? What type of a triangle is it? Isosceles, I see 45, 45, 90. Therefore, if, and I'll keep that up there. Therefore, if this red segment has length √2 divided by 2, what's the length of the blue segment? 1/2, because we've taken √2 divided by 2 and divided by √2. Agree? So, agree. Excellent. So it looks like we do have this nice geometric series. The sum, if our pattern continued indefinitely, would be equal to what? We could take our first term, which is the square root of 2 divided by 2. And what's our common ratio? Is our common ratio square root of 2? Am I multiplying √2 divided by 2 by the square root of 2 to get this segment length? 1 divided by √2. So let's look at that. 1 minus the square root of 2 divided by 2. What do you think about that problem? Good, bad, questionable? If you wanted to go back, and this would give students an opportunity to clean things up if they wanted to, or if the teacher required that. So I'm just going back to our iterate to depth. We can show the building of this by essentially creating an edit action button animation. I might make this run from 0 to 6 just for students to see the building. What grade would I do this? I do this in pre-cal. I've been known to pop it on a BC Calc test, but this is one I really like to put on a pre-calculus exam because we wanted the students to remember geometric series. And then, I mean, if we were in the 2-hour webinar, we could say, well, how could we do this with another special right triangle and things of that nature. So this is just one of those perspectives that I think is helpful. What do you all think? What level of students would you pose this question? Honors, okay. BC? Honors Algebra 2, okay. It really does, I mean, and you can use it in any, with different classes and things of that nature. Now, well, we can go back to this, but what I thought I'd show you is I'd like to do a little run through of the file that I hope you might download when we post these on the we email these or post these to you. I think Elizabeth can probably send us a message on exactly what's happening. But you all could access this Word document that essentially walks us through walks through what we did. And I even had that problem about, and I just gave you a unit circle because, golly, we love unit circles. And then here's a nice little model of the problem that we explored. Now, in addition to the Microsoft Word document, I have this multi-paged document that I wanted to show you because we do have the run-through where you could just present this with your students, and you can drag points and see what's happening to those segment lengths, those representations of the trig ratios. And you see some of the triangles built, and look, they're they're not dynamic triangles. Here, this is just walking it through. I use a smartboard, and so I'm often I have my setup there, and then I continue on. So then I have a few buttons of, well, let's focus in on the representation of the tangent, and I've made the line segment darker, and I ask for us to make a little bit more on the connection realm. As we continue on, you see more of these perspectives. Now, when you go, and then on page 14, you actually see the problem that we just did, and that's built. So you could access that. As you continue on, I've just popped in something I use with my geometry students that involves no trig, but more about transformations. And I'm asking students if point P has been rotated about point O, 30 degrees, what would be the coordinates of point A, and things that we might do in a geometry class. And I just show our special right triangles. Another thing that I wanted to show you, and this is, I feel like what we did with the dynamic unit circle hopefully demonstrated a way to share that the tangent ratio will have a negative value in the second quadrant without necessarily learning a little mnemonic device. But there are times in which little quizzes can help students. And so this is the next set of pages consist of files that I will shoot out to my students. And I have a few students who have the iPads, and with iPads they download, they have their the Sketchpad Explorer, and they quiz themselves. Like here, I'm just using some text and hide show buttons, but I have a little, what's the sine of pi fourths? And the students have root 2 divided by 2. What's the cosine of pi halves? And they can quiz themselves. So this is, I just wanted to give you all a little bit of flavor of the different ways I use Sketchpad in primarily a pre-calculus or BC calculus class. So these files will be emailed to you via a zip down the road. What questions do you have, or any follow-ups from these perspectives? Deborah says, that's so nice since flashcards don't have math symbols. Yes, I'm with you. I have that challenge in using Quizdom because I want to use calculus symbols, and Homey don't play that, or Quizdom don't play that, right? Are there any? Go ahead. I'm sorry.
I was going to say, Melissa, that was a fantastic webinar, and mostly you're getting lots of thank yous for organizing your material so well and for such a great presentation. And I'm not seeing any other questions coming up, but you seem to get to the questions faster than I do anyway. But it is pretty much the end of the hour, so unless you had something more to say, I was going to just thank you for such a fantastic job.
Well, thank you very much, and yes, I'm feeling good, and I hope everyone will be receiving these files, and email me if you ever want to share anything. Have a great day.
Yes, everyone will be receiving a follow-up email. First of all, right when you exit today, there'll be a survey that we'd appreciate if you fill out, and you will all receive a follow-up email which will have links to both today's recording as well as to all of the materials that were presented. And you'll be receiving that within the next day or two, and everything should be up by Friday at the latest. At that point, you'll be able to download Melissa's sketch that she just walked us through with all of the fabulous resources. And you will, in that follow-up email will also be information about the certificates. So it is exactly an hour since we started, so I'd like to thank all of you for joining us today for this webinar, and I want to thank Melissa again for a fantastic presentation, and we hope to have you come to our future webinars. Also, please take a look at what we have to offer at keypress.com, and well, thank you very much. I'm going to end the webinar. Thanks again for joining us. Yeah, you can click at keypress.com/webinars for upcoming webinars to see what's coming up next.